Well, the inner circle, no surprise, they have big support around Punxsutawney Phil. They say he is accurate 100% of the time. That may be a little biased, though. Hello, welcome to Weatherwise. It is episode number 7. I am your host, meteorologist Nathan Scott. February 2nd, that is Groundhog Day, and we'll talk about basically why this all came to be in the first place. Why is this guy known as the perfect prognosticator, at least in Punxsutawney, Pennsylvania? And how good is he when it comes to accuracy on whether or not we've had winters that continue or spring does arrive early? Then we'll switch gears and talk about the processes of water, how it goes from ice to liquid to a solid or to vapor, and then the processes in between each of those phases and why we have frost that forms and why dew forms. Finally, we'll discuss, since we're going into February, all the stats that you need to know about the month of February in terms of the wettest February on record, the driest, the hottest, and also the coldest temperature on record for the month of February. But let's talk about what's behind me. That's Punxsutawney Phil. And this guy is going to be very popular as we go into the next week because everybody wants to know, does he see a shadow or will he not see a shadow? Will winter continue for another 6 weeks or will we see an early spring? So how did this come to be in the first place? When we take a look, we go back to history, and I've done some research. It all originates from a Christian holiday known as Candlemas. And this is when Christians would take their candles to church to be blessed. Now, Candlemas back long time ago, when Jesus was born, still plays a part in this holiday. And this is all a part of the Christmas season that officially ends 40 days after the 25th. This is when Mary brought Jesus to the temple to be dedicated to God. And it's actually halfway between the winter solstice and the spring equinox. So doing more research, they actually have a poem or a song for a Candlemas, and it goes like this. If Candlemas be fair and bright, come winter, have another flight. If Candlemas brings clouds and rain, go winter, and come not again. You think about this, though, and it's like, okay, if it's sunny on that day, Groundhog Day, and it could be warm, then why would they think that all of a sudden a winter would still be in play? I would think it'd be the other way around. If I walked outside and saw it cloudy, rainy, or probably snow, I would think winter would still stick around, but it's vice versa. So when we take a look at this, how did this come to be from candles to getting into a rodent or other animals? Well, it's all because of Germany. At some point, animals were introduced into this folklore, and at first they used hedgehogs because you could find hedgehogs in Germany, and they used those guys for the weather prognosticators. But when the Germans came here to America, they couldn't find any hedgehogs, so they resorted to a groundhog to carry on the tradition. So when it comes to the accuracy, and this is just looking at Punxsutawney Phil, because once again, if he sees a shadow, then supposedly we will have 6 more weeks of winter. But if he doesn't see a shadow, then we're supposed to have an early spring. Well, the inner circle, no surprise, they have big support around Punxsutawney Phil. They say he is accurate 100% of the time. That may be a little biased, though, because when we take a look at the actual science, according to the National Oceanic Atmospheric Administration, or NOAA, they give Phil a failing grade of 40% that he's accurate versus he's not. So that's not a good grade, and you can go back and look at all the details of Punxsutawney. If you just go Google Punxsutawney Phil, it'll take you to a website all about the history of Phil, the inner circle, and also all the different predictions on what Phil has been making over the past several years. This goes all the way back to 1886, by the way. That was the first time that Punxsutawney, Pennsylvania actually recorded their first prediction from a groundhog. But Phil's not the only one in the crowd. There's other rodents all across America that people resort to and look to a forecast for the upcoming spring going into the final days of winter. Here are the other names. We've got one from Pennsylvania, and that's pretty close to Lancaster, Pennsylvania, actually Quarryville, Pennsylvania. Then Ohio, no surprise, Buckeye, Chuck. Dunkirk, Dave in New York, a popular rodent. And Staten Island, Chuck. So I wonder if Dunkirk, Dave and Staten Island, Chuck kind of disagree from time to time. So there's just a little brief history on Groundhog Day. But let's switch things over and talk about another holiday that's coming up. That's February 5th, and that's known as National Weather Person's Day. And this is all thanks to the birth of John Jeffries back in 1744. He was one of the first American weather observers that made his observation 30 years later, 1774. And in 1784, he took the first balloon observation over England that had a thermometer, a barometer, which measures pressure, and a hygrometer, which measures humidity, all the way up to 9,000 feet. So that is pretty impressive when it comes to the first observations made by, I guess you could say, an actual meteorologist. Long-term forecasting, though, is always a challenge, even though we do have the ability to make a long-term forecast because weather models can give us an idea on how the waves of the atmosphere will work. And that long-term forecast is actually done by the Climate Prediction Center. So let's go over to Storm Track 11. This is what the forecast is currently by the Climate Prediction Center. And this is the next 6 to 10 day outlook. So this goes from February 1st to February 5th. You see the red, that's above average. Now, this doesn't tell you how much above average the temperature will actually be. This just tells you the odds of seeing the temperature above average. The higher that it goes in the darker reds, that's a higher percentage. Meanwhile, it looks like the colder air is going to be locked up into the Pacific Northwest and also into the northern plains. And that's because the jet stream is going to be taking a dive to the western part of the country, and then a ridge will build over the eastern half of the country, allowing much warmer air. And take a look at the 8 to 14 day outlook. Look what happens. That jet stream continues to push its way to the east, so the probability of more cold air pushing more into Kansas and Oklahoma will be going up. Here in Arkansas, we're right on the edge. So looking at this type of pattern between the cold air off to the west, the warm air off to the east, we will likely see unsettled weather as we go into the month of February with rounds of storms moving through, storm systems making their way across the country that will bring the potential of heavy rain. And there is a good chance of heavy rain moving into Arkansas as we get into later Wednesday night, Thursday, especially Thursday night, and then exiting Friday morning, just because we had this active weather pattern shaping up. The good news is right now, looks like the severe weather threat is primarily going to stay out of Arkansas. We'll have a lot of wind energy, but at this time, as of Monday afternoon, it looks like we won't have storm fuel for those storms to tap into and to rotate. Nonetheless, heavy rain can still cause some minor flash flooding issues. Of course, we'll keep you updated here on THV 11. That's it with the brief history of Groundhog Day. Next topic we'll discuss will be the processes of water. Stay tuned. Welcome back to WeatherWise. For this segment, we'll delve into more science behind meteorology and weather in terms of talking about the processes of water as it goes from the ice phase to the water phase to the vapor phase. There's different names for that. And then also what happens and how that's used in meteorology. So what I want you to think about is what's going on as you're seeing water as ice, water as liquid, water as vapor. And we have to look at the molecular structure of what's happening at that time. So when you have molecules as a gas, think about having a box of balls and you're shaking that box a lot. And those balls are just going in all kinds of directions. the faster that you shake them. So that is pretty much the gas phase of water. Shake it a little bit lower or slower, and then the balls don't move around as much. So therefore, that is more like the liquid phase. Now, just stop shaking the box altogether. The balls don't move at all, and that's what's known as the solid phase of matter, or in this term, water changes over to ice. So think about that as we go through the processes of water. First of all, when we go from ice, melting of ice to water, of course, it's known as the melting process. Then when we go from water to vapor, that's known as evaporation. Pretty simple, right? Still have your attention? Well, think about this as well. Melting and evaporation are known as cooling processes. Now, how can that be? When you add heat to water, that's what allows the water molecules to change over to vapor. Here's the reason behind that. Because you are taking heat away from the surrounding environment. If you've ever gotten out of a pool on a not humid day and you have water on you, your arms, your legs, you notice that all of a sudden you get out of the pool, you feel chill bumps or goosebumps. And that's just because as those water droplets are evaporating due to the dry air, they are taking heat away from the environment. That drops the temperature, and that gives you that cooling sensation when those water droplets evaporate. So this is known as evaporative cooling. Let's go back over to the chart now, because we're going to go the other direction. We're going to go from vapor to water, and that's known as what? Condensation. You see that clearly when you are taking a hot steamy shower. Condensation forms on the mirrors, on the glass, and can cause some issues if it's lingering there for a long period of time. As you know, it can cause some mold. Then from water to ice, it's freezing. And that's just because, remember those molecules, when we go from vapor to water, the molecules start to slow down. They slow down even more and almost stop when we go from water to ice. That's what allows it to become a solid. Have you ever seen ice go to vapor or vapor go to ice? It does happen, and that's known as deposition. So when we go from air to ice, that process is known as deposition. And can you think of something that you see all the time in the winter when you wake up in the morning that shows this process? Frost is that process, because frost happens when there's no clouds. It has to be a clear night. The winds are calm, and you have to have moisture in the atmosphere. So as the temperature, the air temperature, cools down to the dew point, and the dew point is how much moisture there is in the atmosphere, but in this case, the dew point becomes the frost point because it's below freezing. So as the air temperature cools below 32 or at 32 and below, that vapor will go automatically to a solid, and that's what creates frost. Now, it doesn't always occur just because it's cold, because if it's too dry of an air mass, the air temperature never drops down to the frost point, and you don't have that transition happening. Now, we can also go from a solid to a gas, or from ice to vapor, and that process is known as sublimation. And you see that when the frost disappears. Usually the frost doesn't melt on the grass. You don't see droplets of water. It just disappears back into a vapor. So once again, as you go from left to right, this is a cooling process. When you go from right to left, that's known as a warming process. And especially it's important in meteorology, because when you go from vapor to water or condensation, you are releasing something known as latent heat. And latent heat is a very important process when it comes to a hurricane, because that latent heat basically acts like an engine for hurricanes and tropical storms, as that system feeds off the warm waters of the ocean, produces the clouds, produces the condensation, produces this latent heat effect, and that's why you continue to see storms develop, because they're feeding off of that. More and more energy is going into the storm system, and you get that effect. So that's just a little bit of science for you. We'll get into more science topics as we go into more episodes. We'll take a break right now, and we'll be back with more Weatherwise after this. Well, we are saying goodbye to January, hello to February, and when we take a look at the breakdown of all the interesting statistics on maybe the hottest temperature for February, the coldest temperature, here it is. The hottest temperature we've reached during the month of February at Little Rock now, 87 back in 1918. The coldest, 12 below zero back in 1899. The wettest month on record for February was from 2018. We had over 14 inches of rain. The driest, just over a half inch of rain back in 1947. And also we have the average high at 52 degrees for the first day of the month. But by the end of the month, we are seeing the temperature get up to around 59 for your average high. And that should be the 28th, not the 29th, because we're not in a leap year. As for low temperatures, your average low is 32 degrees for the first day of the month, and then the average high by the end of the month is 37. Rainfall is pretty close to 4 inches on average. And look at your sunrise and sunset. Your sunrise 7:07, it sets at 5:38, but by the end of the month, the sunrise will be at 6:39, and your sunset happens at 6:04. Usually we also have our first 70-degree day, and here's the breakdown on that once again for Little Rock. You see the past years. Last year we had our first 70-degree day, January 30th, 2023. It happened the first of the year. Same story for 2022. We have not seen the latest first 70-degree day in February since 2020. And you see there the latest one for the past 10 years was back on February 15th in 2018. So the earliest, of course, the top of the year, on average, we have our first 70-degree day around January 25th, and these records go all the way back to the 1890s. The latest one, that was April 5th, back in 1915. And I think we're going to get pretty close to 70, or 70 will certainly be a possibility going into this weekend. As temperatures will climb up into the upper 60s by Sunday, we could make a run at 70 easily with a west-southwest wind developing. Now, you remember last year, there were spring bulbs already coming up by the middle of February, and that's just because it was warm. We had 12 days that temperatures climbed at least to 70 degrees for the month of February, and that's the most 70-degree days that have ever been recorded for the month of February. So last year was an outlier 100%. And when you take a look at the warmest Februarys on record, it was also the warmest February on record. When you take all the average highs, or you average out all the highs and average out all the lows, you get this number by taking the average highs, all the average lows, and average that number out. There you see our monthly average temperature was 54.8 degrees last year. Will this year be a repeat? We're going to see some warmer weather, but we also have that Arctic air still waiting in the wings. So I think we're going to see wild swings throughout the month of February. We're going to have some 70s. We certainly could hit 80, but I don't think we're done with winter just yet. Well, that's all I have here for today's Weatherwise. As always, thanks for watching, and don't forget to send me your questions. Let me know what topic you want me to discuss. It can be a weather topic, or it can be, hey, I took this picture. What created this cloud? What am I seeing here? We'll discuss all that, but I need your help. So don't forget to send those pictures in or questions in. You can email me at nscott@thv11.com, or you can reach me on my Facebook page as well. All you have to do, put in the search engine on Facebook, Nathan Scott, THV11, and I'm sure you'll find it. Well, thank you for watching. Have a great afternoon, and I'll see you soon.